Today, we're going to add depth to our water shader in Unreal and Unity. Let's go. Alright, for the last couple of weeks, we've been creating this cool looking water shader. We animated the waves, we added surface ripples, and then last week we added refraction so that the water refracts the light and distorts what's below it. You can see that going on here. Today, we'll add depth to our water. We'll start out in Unreal, and then we'll switch over to Unity and do the same thing there. Now, if you've been subscribed to my channel for a while, you may remember that about 3 years ago, we worked on a similar shader, and I showed how to add depth to water. But what I'm going to show today is the new and improved version. I've hammered on this a little bit and found some ways to optimize and make it a little bit more streamlined. So if you take a look at what we have now, you can see that no matter how far away from the surface we are, or how far away or how deep under the surface the objects are, they're always the same amount of opacity, or you can always see the objects the same. There's no depth happening here, and so that's what we're going to add in our shader today. All right, so we'll switch over to our shader, and this is what we've created in the last couple of weeks. Here are our Gerstner waves that we created at the beginning. And then these are our surface ripples here. And then last week we added these nodes here to create our opacity. So we're going to be adding and modifying this portion here to add our depth to our opacity. So the first thing that we need to do in order to create depth is we need to add a scene depth node. And what this does is, so our water is transparent, and so its depth doesn't count for the scene depth node. What this is going to give us is the depth of the objects that are behind the water. So the rocks underneath the water, for example. This is going to give us the distance from the camera to those objects. And we're going to divide our scene depth by our pixel depth. And the pixel depth is going to give us the distance to the surface of the water plane. Now, one thing that we need to watch out for, you may have noticed that the output ports here are red, and that means that these two nodes cannot be used in the vertex shader. We've been talking a lot about vertex shaders recently, and we've been able to optimize things by adding these vertex interpolator nodes. But since these two nodes have these red output ports, that means these operations cannot be done in the vertex shader. We have to do this portion in the pixel shader. Now, the next thing that we want to add here is a camera position node. This is going to give us the position of the camera in world space. And for the camera position node, we only want the Z component of that. And so we're going to use this mask here to mask off just the B channel, or the Z component of our camera position. And then from that, we're going to subtract a hard-coded value of 1. All right, now I'm just going to scoot these nodes back a little bit to give myself some more space. And now I'm going to multiply my result here by a value of -1. And now I'm going to multiply the result of that by my scene depth divided by my pixel depth. And now I'm going to take the result of this and add in my camera position's Z component with a subtraction of 1 there. Alright, so we're getting pretty close here. I'm just going to invert my result by adding a 1-. And now I'm going to add a couple of nodes that are going to give me a little bit of control over the result. We're going to divide by a constant value, and this constant is going to control my maximum depth. So I'm going to give it 200 for 200 centimeters. You know, obviously in Unreal, everything's measured in centimeters. So this is going to be my maximum depth, 200 centimeters there, 2 meters. And then I'm going to add a power node, and this is going to allow me to control the fall off. So I'm just going to give it a fall off of 0.5 for now. Linear fall off would be just a power of 1, but I'll show you in a minute. We can play around with this value. Okay, now with these nodes laid down, I can go ahead and plug this in. What I'm going to do really quickly, just so that we can visualize what's happening here, is I'm going to change my roughness to 1, which is going to get rid of my reflections. And then I'm going to disconnect my opacity here, and I'm going to plug this value into color. And so what we're going to be able to do is visualize what the depth that we're calculating here looks like on our water surface. So I'm just going to go ahead and save this. And we'll switch over to our viewpoint port, and now we can take a look at what our depth looks like. All right, so I've used those nodes to calculate how deep our water is, and you can see that where it's shallow, I'm getting a value of black, and then the deeper it is, the closer to white I get. If I want the maximum depth to be higher, I can put something like 800 in here, and now you can see that I'm getting values significantly further down into the water. And if I want the fall off to be linear, this might look a little bit nicer when we're previewing it. Yeah, there you go. So with linear fall off and 8 meters of depth, you can visualize the depth on our water pretty well. That looks really cool. I like that result. The thing is though, this looks nice when we're visualizing it here in the viewport, but what we really want it to look nice is when we're actually using it as water. And so for me, I've found that these values here, 2 meters and a fall off of 0.5 look nice. All right, well, let's go ahead and plug this into our opacity. And we'll set our roughness back to 0 to give us our reflections. And we'll disconnect our base color there. And now let's take a look at our result. All right, so now you can see when I look down into the water, past that certain depth value, my water is opaque, and then above that depth value, my water is transparent. All right, but last week when we were working on our opacity, we actually had a Fresnel term so that our water would be opaque when we were looking at it kind of edge on like this. And we need to take our Fresnel term that we were using and combine it with this depth that we just created. Because right now, we're only calculating our opacity with depth, and we're not taking into account the Fresnel. So what we can do is just create an add node here. And I'm just going to take my Fresnel node and plug that right into the depth that I've already calculated. And now that can become our new opacity. The nice thing that I realized about this Fresnel node, if I mouse over this normal input, it says that it defaults to pixel world normal if not specified. So I don't even have to connect up my normals here like I was before. I can just leave it disconnected and it'll go ahead and use that pixel world normal just automatically. So I'm going to hit save and we can take a look at our result. So now you can see, now that I'm looking straight across the water, the Fresnel node is making it so that this portion of the water is opaque. And then when I look down into the water, it's more transparent. But my depth is then kicking in so that my water is opaque down here where it's deep, but then transparent here where it's shallow. There are still a couple of things that I want to fix. For one, the water looks kind of like it has this hard edge. And there are two things that are contributing to that. First of all, water is going to refract less when it's really shallow like this. Right now it's doing the full amount of refraction, even here where it's just lapping right up to the edge. And second, I can actually boost the amount of transparency that's happening where my water is intersecting these other opaque objects. So let's go ahead and do both of those things. In order to enhance my opacity, I'm going to add a node here that's called depth fade. And if we just mouse over this depth fade node here, if I hold Control and Alt, you can see that this is a node that's used to hide unsightly seams that take place when translucent objects intersect with opaque objects. So that sounds like exactly what we were looking for. And so I can just take this depth fade node here, and I'm going to give it a fade distance of 30 centimeters. And I can just multiply this with my opacity calculation to get a better opacity. And then I can also use this fade depth down here with my refraction. So last time we talked about this refraction value. One thing that I failed to mention, and somebody pointed out in the comments, the index of refraction of water is actually 1.333, right? But I'm using a value of 0.75 because in order to get the correct value here for refraction, what we need to do is take the refraction value of air, which is 1.00003, something like that, 1 with a very, very small number after it, and then divide that by 1.33. So we divide the index of refraction of air by the index of refraction of water, and that's what gives us this 0.75 value. All right, so if we want a refraction value that does nothing, we just need a value of 1. So if I give it a refraction value of 1, that's basically like saying I don't want refraction. And so if I want to turn my refraction off, I can just use that value of 1. So what I'm going to do is blend between 1 and 0.75. So this is basically like refraction off, refraction on. And I'm going to use this depth fade value to do that. So I'm going to just plug this into the alpha input of my lerp, and then I'm going to plug that into my refraction value. So basically what this is doing is around the edges where this depth fade is kicking in, I'm going to give it a refraction value of 1, and then everywhere else I'm going to blend into a refraction value of 0.75. All right, let's go ahead and save this, and we'll take a look at our result. Okay, so now you can see that that hard line that we had before has been blended out really nicely. And it's really hard to make out the border in between our water and where it intersects with our objects, which is a little bit more realistic looking. All right, so we added depth to our water. That's pretty cool. One more time, what I want to do is set our value here, turn off our reflections, disconnect our opacity, and plug our depth value here, our opacity value that we're calculating, into color so that we can visualize it. And what I want to show you is what this depth fade value is doing. So if we switch over here, yeah, now you can see it. So we have this really nice fall off of depth where we're looking down into the water. But then right around the edges of things, you can see that that depth falls off really quickly directly to black. And that's what this depth fade node is contributing to the rest of the depth value I'm calculating here. And we also see the contribution of our Fresnel node if we're looking kind of across the surface rather than directly down into it. You can see that our color is significantly more opaque. It's a lot more white. Whereas if we look down into the surface, we're getting more of that depth value, and that's the contribution of the Fresnel. All right, so the elements that we went over today, we calculated the depth of our water with these nodes here, and we included these values here. This is 200 centimeters of maximum depth, and then kind of a linear versus, we can control the fall off of that depth opacity. Then we added our Fresnel term here so that our water is more opaque when looking at it at glancing angles. And finally, we added this depth fade node here so that we can get kind of a fade out at the edges of the water. And we use that to both control the opacity as well as to control the amount of refraction that's happening. And that works to soften the edges. All right, so there is our water shader as it currently stands. We have really nice Gerstner waves creating these large deformations of the water surface. Then we've got these scrolling normal maps that create the nice ripples. And then we've created our really nice opacity values using Fresnel, depth fade, and also those water depth calculations. All right, let me know what you'd like to see next week. I'm thinking maybe we'll add some surface foam to our water. That'd be a good spot to go. That's it for now. Let's switch over to Unity and I'll show you how to do the same depth calculation there. All right, here we are in Unity. And if you'll remember from last week, we did some really interesting things here in Unity because we have control over the color that we're getting underneath the water. I don't know if you can see, it's kind of subtle, but there's some chromatic aberration going on here. And if we take a look at our shader, what you can see is we're sampling our scene color underneath the water. And we're actually sampling it 3 times. And each time we sample it, we're creating our texture coordinates offset using our surface normals. But here we're multiplying by 0.05, 0.04, and 0.03. And then for each of these samples that we take, we're actually using these different offset amounts for the red, green, and blue channels. And then we combine those colors together to create our final color. So we're creating different amounts of refraction for red, green, and blue. And that's what gives us our chromatic aberration. We're able to go a little bit further with the refraction and split apart the red, green, and blue there. All right, so let's add the depth. Just like we did in Unreal, we're going to go ahead and add depth to our water here. You can see that no matter how far away or how deep the water is, everything looks basically the same here. And so we're going to remedy that. So I'm going to go ahead and add an HD scene depth node. And this node is specific for URP or for HDRP, but if you're using URP, you can actually use the scene depth node instead. Okay, so we're going to go ahead and subtract our scene depth from... So this is the depth of the water, or the depth of the objects that are underneath the water. And to get the depth of the objects that are on the water itself, we can put down a screen position node and put it in raw. And then we can take the W component, so I'm just going to use swizzle and W, and that's going to give us the distance from the camera into the scene. So we're going to subtract the HD scene, or we're going to subtract the depth of the water's surface from the scene depth, and that will give us the distance from the water's surface to the objects that are behind it. And then we're going to divide that by the value that controls our maximum depth. And in this case, we're going to make our maximum depth 5 meters. All right, and then we can saturate our result. And then just like we did in Unreal, we're going to apply a power node that will allow us to control the fall off. So again, we're going to give it a fall off of 0.5. All right, and then this is going to give us a pretty good approximation of water depth. So just so that we can visualize what these nodes here are giving us, I'm going to plug this into color. And I'm going to set our smoothness to 0 just to get rid of our reflections. And this should show us what our depth colors look like. All right, so I'll save it. And it looks like I forgot one thing that's really important. We need to set the HD scene depth here to I instead of linear. Okay, so now you can see the depth of the scene. You can see that right here on the edge where the water is really close, there's kind of this black line. And then here you can see these details. And this is a really good indication here. You can see it's kind of darker here at the top step. And then as we go down the steps, we get further or closer and closer to a value of 1 with our depth. So that's showing you our depth calculation. You can see here as we get deeper into the water, it goes from black down to a value of white. So that's what our depth map is doing. Now, there are a whole bunch of different things that we can do with this. First of all, we can take our Fresnel effect and we can add it to our depth so that we get some nice opacity at glancing angles as well. So let's go ahead and plug this into our color and take a look at our result. Yeah, so now you can see that when I look at the scene at a glancing angle like this, and I'm getting these really nice waves going on here too, which improve the glancing angle. So the depth is more opaque at glancing angles than it is when I'm looking directly down into the water. All right, now I need to make sure that if I'm going to use the depth value that I saturate it after I add the Fresnel to it. So I'm going to go ahead and add a saturate node here. And now we can use this depth. So here we're blending between the color of the scene under the water and the opaque color of the water itself. And now we can use this new value that we've calculated to calculate that water color. So all of these nodes here represent what we're seeing through the water, the refraction amount. And then this is the opaque color of the water, where it's going to be this color at glancing angles and also in places where it's deep. So we're blending between this color and this color based on this value that we've calculated here using our Fresnel and our depth mask. Okay, so now we can plug this into our color and maybe we turn back on our smoothness here so we get our reflections. Yeah, okay. Now we're making some really good progress. You can see these areas where the water is deeper, where it goes from a transparent color all the way down to our opaque blue color that we've chosen. So that's pretty cool. It's working the way that we want it to. Now there are two more things that we can do. Remember that here when we're sampling our HD scene color, we're actually sampling MipMap 2 of our HD scene color. Normally we would set this to 0 to sample the full resolution, and I'll show you what that looks like. Yeah, now you can see under the water these areas here look a lot sharper because we're actually sampling the full resolution of HD scene color. But if we set that to 2, what it does is it makes it look like the water is blurring the scene under the water. Now the really cool thing here is because we have this depth value, we could actually make the water get blurrier as it gets deeper. And so what I'm going to do is take this depth value and I'm going to multiply it by 3. And so what this is doing is, like, the deeper it gets, the closer it gets to 1 in the depth mask here, it's going to go to a value of 3. So if I wire this into the LOD connection here on my HD scene color, the deeper our water is, the blurrier it's getting. So I'll save this. And now you can see, yeah, that's pretty cool. So right here where the pillar is really deep, you can see that it's quite blurry. But right here where it's shallow, we're getting it nice and sharp. Let's just go ahead and see if we can move our water plane down so that more shallow the water is, the sharper the scene is going to be. Right, so you can see it's nice and sharp there. But then, if I make this water deeper, well, maybe you won't even be able to see because it's so deep. But now, yeah, on this pillar here, you can see it's nice and blurry. So we made it so that the deeper our water gets, the blurrier it is underneath the water. That's pretty cool. We can also do the same thing with our chromatic aberration. So let's go ahead and do that. So this value here, this HD scene color, we can use this for a sharp scene. So I'm just going to add another lerp node here. So what we want to do is when the scene is shallow, when the water is shallow, we can use this HD scene color value. But when the water is deep, we can use this combined value here of the red, green, and blue that's doing the chromatic aberration. So now we can use our depth mask here to blend between our non-chromatic aberration value here and our combined chromatic aberration value here. So the deeper the water gets, the more chromatic aberration is being applied. All right, let's save that and see what we get. Right, so now what you can see is there's no chromatic aberration here near the surface, but then, down here at the bottom of the steps there, the chromatic aberration gets stronger and stronger. So in addition to adding depth to our scene, now we've also used the depth to control the blurriness of the underwater appearance, and also the amount of chromatic aberration that we're applying. Of course, all of these things are not necessarily required to make our water shader, but it is pretty cool that we can do these things in Unity. All right, so here is our water shader. We've applied our depth value, and we've made it so that we fade from transparent water near the surface to opaque water where it's much deeper. Actually, you know what? I'm going to switch this value here. We're going to go with 8 meters for our depth, just so you can get a better idea of what that depth is doing. Yeah, that's cool looking. All right. So today we added depth in Unreal and Unity, and we combined our depth with the Fresnel term to create the final opacity for our water. And in Unity, we're actually able to use the depth to add an additional chromatic aberration and depth blur term to our water as well. All right, I hope you enjoyed today's video. Sorry for my voice, I've got a little bit of a cold. I hope you don't mind too much. Next week, we'll be adding foam to our water, so come back for that. And in the meantime, have a great week.